Are you guys following me? Simple molecular structures. Simple molecular structures in terms of covalent
Yes, sir.
compounds. Covalent compounds, right? Covalent compounds. We are going to see two major covalent compounds: simple molecular structures and giant covalent structures. Giant covalent structures. When we discuss simple molecular structures, generally these are the ones that we are talking about: molecule of elements and molecule of compounds. These ones, all right? Then we say that the covalent compounds, these simple molecular structures, generally they have intermolecular forces. Intermolecular forces. They have intermolecular forces, and intermolecular forces are of many types, right? There are different types. The one that we would want to discuss over here is van der Waals forces. Der Waal van der Waals forces. Okay, these are the ones that we would want to discuss, van der Waals forces, because we see that different compounds, this is gas, this is gas, all right, this is liquid, this is gas, this is gas. So we generally see that even though they are same molecule, they are the same, they are covalent compounds, but they have different states, right? Like if you look at iodine, this is solid. Do you get it? They are all covalent compounds, but they have different states. And the reason of difference in their states are the intermolecular forces, specifically van der Waals forces. Do you understand this point, everyone? Generally, it is not for you to understand how these van der Waals forces generally are created, but we know that basically, I want you to have a little bit of understanding of this. Basically, if you look at an iodine molecule, let's say if you look at hydrogen molecule, right? Hydrogen molecule is going to be something like this, right? Another hydrogen molecule is here, right? So these are two hydrogen molecules, and we are saying that there are weak intermolecular forces present between these two molecules, right? Which is called van der Waals forces. Van der Waals forces, when we talk about them, they actually keep, what are they doing? They keep the molecules closer together. As they become stronger, as they become stronger, the substance becomes solid. As they become weaker, the substance move towards being liquid and then a gas. Is it making sense, right? We've already studied this. We've already studied that when the change in state takes place, basically what is happening when a change in state is taking place, these van der Waals forces, these intermolecular forces are being overcome by the kinetic energy of the particles, right? Hmm? So basically, as they become closer, these van der Waals forces become stronger, and they keep pulling the molecules closer together, and the substance or the sample is going to be moving towards becoming liquid and then gradually become a solid. That as what takes place if you look at steam that condenses to become liquid, then it freezes to become a solid ice. Do you understand? Ilian, do you get it? Any queries up to now? Alishba, do you understand?
Yes, sir.
All right. So this only exists where? This only exists in covalent compounds, molecules, right? How do generally, this is not in really in your course, but if you want to know a little bit of it, basically what happens is that these, I want you to concentrate here very carefully and look at it. This is the two,
जी सर मैं ध्यान दे रही
right? देखिएगा, this is hydrogen, right? So these molecules do not just stay in the middle over here. These electrons, sorry, these electrons do not just stay here. They are moving in the shell because they are the electrons of the outermost shell. So they are, and both of them, we used to count this in this manner, right? This hydrogen, this atom has two electrons, 1 and 2, in its outermost shell to form a duplet. Similarly, this atom also has two electrons, 1 and 2, as its duplet, right? So what it means is that these two electrons, they generally are moving in both of them. Do you get it? Like
Yes.
this. They move in both of them like this. Do you get it? It's not that they get stuck over here in the middle. It's not that they get stuck here in the middle, but actually these electrons are moving all the way around in each of these shells, right? And for both of them. So when both of these two electrons, they go on one side, if they, let's say if they move, if they have moved from here and they are now in this region of the orbit. You get it? So what happens is that, are there any electrons over here in this region at the moment for hydrogen? This region becomes, this region has more electrons in this side, right? So it becomes negative for some time and this becomes positive for some time. Then next instant they might move from here somewhere. So now this becomes positive and this becomes negative. You understand this point, everyone?
Yes.
So these charges keep fluctuating. All right. So the neighboring atoms or molecules are also affected by change in this charge. When this becomes negative, this becomes positive. When this becomes positive, this becomes negative. So they keep fluctuating and they keep attracting each other. Do you understand? This is how the intermolecular attraction actually is there. Is this clear? Ilian, did you get it? This is a very
सर
important
फिर
point.
से समझाएंगे
Right. We are saying that we are saying that basically there are intermolecular forces that we are able to observe, right? Intermolecular forces between atoms. Which part is it that you didn't understand, Ilian? Which part exactly? We are saying that this is an hydrogen atom, right? These are the electrons that are present in hydrogen atom molecule. This is an H2, a hydrogen molecule, and there we know that there are many hydrogen molecules, and we know that there is an intermolecular forces between the covalent molecules. The simple covalent molecules, for, they have some forces of attraction in between them, right?
Yes.
And that is intermolecular force generally. So this hydrogen molecule and this hydrogen molecule and this hydrogen molecule and this hydrogen molecule, all of them, they have a forces of attraction between them. How is that really taking place? We say
Yes.
that the forces of attraction is due to the uneven distribution of electron that takes instantaneously. When is that? We say that electrons do not really get stuck over here for all of that time. They are actually moving. They actually move like this in the outermost shells of both of these atoms, right? So there comes a point in time when the electrons are present here, and there comes a point in time where these electrons are present here. There comes a point in time when these electrons are present here somewhere. You see, so they keep on moving in the outermost shell for both of them, because these two electrons are actually making a duplet configuration, not for only one hydrogen but both of them. So it travels to both of them. They keeps on moving in both of them. We know the electrons are always moving in their shells, in their orbits, right? So when these electrons have moved from here to here or anywhere else, so there is an uneven distribution of electrons. All the electrons are actually accumulated on this side for whatever, for how many were there, whatever was the number, they are all accumulated at this side. So this side becomes negative, and generally this side becomes electron deficient, so this becomes positive. You understand this point?
Yes. Yes.
Yes, sir.
Similarly, when the electrons have moved on this side becomes there are more electrons here, so this side becomes negative and this side becomes positive, right? So this fluctuating is taking place at all times. So at all times, so the neighboring atoms, the neighboring molecules are affected by this. When this becomes positive, this side is going to become negative and this side is going to become positive for hydrogen. You get it? The electrons are going to be here somewhere. So there's an attraction of positive and negative that is constantly taking place, but you have to keep in mind covalent compounds do not make ions. Please keep that in mind. Ions are only present in ionic compounds. They do not make ions. The ions are not made here. Is this clear to you? Have you understood this? If you are not able to retain this, no problem. If you're not able to keep up with this, whatever I was able to understand,
Yes.
don't worry. Okay? Don't worry. Even if you're not able to cope up with this, don't worry. You have to keep in mind that there is an intermolecular force that exists between the molecules, which is called van der Waals forces, between the molecules of the covalent compounds. All right. And what is this intermolecular force? Intermolecular force, which is van der Waals force particularly. There are many type of intermolecular forces. We are actually studying van der Waals forces. Van der Waals force. Do you get it? We talk about van der Waals
Yes.
force. It depends upon what? These intermolecular forces, this van der Waals force that exists between the two covalent compounds, between the between the molecules of a covalent compound or a simple molecule, is actually the number of electrons. Higher the number of electrons, the stronger will be the force, and the number of atoms, right? Higher the electrons, higher the number of electrons, more forces of attraction there is going to be. Let's take an example. You see, this is C4H10. Okay, and there is a compound which is let's say CH4, and there is a compound which is C8H10. This is a gas and this is a liquid. You understand? The reason, there is a higher number of electron present here, so the van der Waals force was stronger. The particles were able to come closer and they became liquid, and the whole of this compound seems to be liquid. Do you understand this point? And comparing with this, the number of electrons were lower, the number of atoms are also lower. How many atoms are there in this molecule? Can anybody tell? Yes, सलिशबा बताएं, एलिन बताएं जल्दी से.
Sir, जी sir.
How many number of atoms are there in this compound? 5. There's 1 carbon and there are 4 hydrogens. Total there's 5 atoms. How many atoms are there in this molecule? There are 8 carbon
18.
and there hydrogen 10.
18.
So 18. So which has more number of atoms?
C8H10.
Right. So it has more number of atoms. It has more number of atoms and it also has more number of electrons. Right? More atoms mean more electrons. So if the number of electron is higher
Yes.
and the number of atom is higher, if this is higher and this is higher, what is going to be happening? Van der Waals forces or intermolecular forces is going to be stronger. Do you understand this point?
Yes, sir.
All right.
Yes, sir.
All right. This is what we had to understand.